Hello everyone, and welcome to another video in my channel. In this video, we are required to find the value of x given that x squared plus x all over x squared plus 3 as a quantity raised to power 3 minus x minus 3 over x squared plus 3 as a different quantity raised to power 3 is equal to 1. So basically what we'll have is difference of two cubes being equal to 1. So the question is, in the set of integers, are there two numbers whose difference of cubes will be equal to 1? I don't think so. But if there is, I would like to read the answer in the comment section. Since we don't have two numbers in the set of integers whose difference of cubes will give us 1, I will have to use algebraic substitution. So I will make this part be a and this part be equal to b. So I have a cube minus b cube is equal to 1. As simple and neat as this new expression is, I can't solve it like this. So I will have to use an equivalent expression to a cube minus b cube. And for me to use it, I'll have to derive it. I can derive that expression using a minus b all cube. If I expand it using Pascal's triangle, I will have a cube minus 3a squared b plus 3ab squared minus b cube. So let me gather these two last terms together with their sign. So a cube minus b cube, which is the expression we are looking for, minus 3a squared b plus 3ab squared is equal to a minus b cube. So I'll have to move these two last terms to the other side. It becomes a cube minus b cube is equal to a minus b all cube plus 3a squared b when this crosses equal to, and minus 3ab squared when this one crosses equal to. Now simplifying further, I have a minus b all cube. I can factorize 3ab out of these two expressions plus 3ab. It will remain a here and then b. So I have this. I can also factorize a minus b out since it's a common term here. So a minus b in the big brackets, we have a minus b squared, and then when I factorize a minus b out from here, I'll get this plus 3ab. If I factorize a minus b out here, I will have this remaining. Is equal to a cube minus b cube. So the expression I need is this expression. So this expression will now be equal to 1. So a minus b all squared plus 3ab is equal to 1. Now at this point, what I need to do is to back substitute these expressions for a and b into the new expression. So it becomes x squared plus x over x squared plus 3, which is a, minus x minus 3 over x squared plus 3, which is b. Let's put them in the brackets. Then in the big brackets, we have x squared plus x over x squared plus 3, then minus x minus 3 over x squared plus 3. Close the bracket and square it, which is this part, then plus 3, then in the bracket x squared plus x over x squared plus 3, and x minus 3 over x squared plus 3, close the bracket, is equal to 1. Now if we simplify these two fractions, the LCM is x squared plus 3. X squared plus 3 divided by x squared plus 3 will give us 1. 1 times x squared plus x will give us x squared plus x. Then this minus is this. X squared plus 3 divided by x squared plus 3 will give us 1. Then we have x minus 3. In another bracket, the same thing happens. So I have x squared plus 3, since these two terms are exactly these two terms. Now I have x squared plus x minus x minus 3 raised to power 2 plus 3. Then I have here x squared plus x times x minus 3 all over x squared plus 3 all raised to power 2 is equal to 1. Now let us open this bracket. If we open this bracket, we'll have x squared plus x minus x plus 3 all over x squared plus 3. This and this will cancel out. The same thing will happen here since these two terms are the same. X squared plus x minus x minus 3 plus 3 rather all over x squared plus 3. This and this will cancel out. Let's square this. Plus 3 x squared plus x and x minus 3 all over x squared plus 3 squared is equal to 1. We're going to leave this term the way it is and then simplify these other two terms. Now here becomes x squared plus 3 over x squared plus 3, which will give us 1. And then here is x squared plus 3 over x squared plus 3, which will give us 1 again. Then we'll square it plus, I will say that we'll leave this term the way it is. So I have x, so I have 3x squared plus x and x minus 3 all over x squared plus 3 all squared is equal to 1. This divided by this will give us 1. I have 1 here. And this is 1 squared plus 3x squared plus x, x minus 3 all over x squared plus 3 all squared is equal to 1. 1 squared is 1. 1 times 1 is 1. Then 1 minus 1 is 0. So I have 3x squared plus x, x minus 3 all over x squared plus 3 all squared is equal to 0 because 1 minus 1 is 0. If I multiply through by x squared plus 3, what I will have is 3x squared plus x, x minus 3 is equal to 0. This pretty much simplifies the situation for us. So if I distribute this 3, which is outside in the first bracket, I have 3x squared plus x plus 3x, then x minus 3 is equal to 0. I can now equate each bracket to 0. So this is 3x squared plus 3x is equal to 0, or x minus 3 is equal to 0. Let us start with x minus 3 is equal to 0. X will now be equal to 3. This is the first solution. And in the second one, we have 3x squared plus 3x is equal to 0. Then if I factorize x out, x times 3x plus 3 will be equal to 0. Then x is equal to 0, and then 3x plus 3 is equal to 0. Therefore, 3x equals to minus 3, and x equals to minus 1 if I divide both sides by 3. So the solutions are x is equal to 3, x is equal to 0, and x is equal to minus 1.